Now that we have some more sophisticated tricks for counting large sample spaces, let's use these tricks to calculate some probabilities that would have been very difficult to calculate before. Um, so mostly we'll use these tricks to figure out how large very large sample spaces are. For example, if you think about finding the probability of getting a royal flush, that's a 10, jack, queen, king, and ace all in one suit, in a 5-card poker hand, well, as part of that, part of calculating that probability, you need to know how many possible poker hands there are, how many possible 5-card poker hands, and there are an awful lot of them. But using what we know about permutations and n choose r, it's actually pretty easy to write down an expression that will tell us how many 5-card poker hands there are. So to choose a 5-card poker hand, we have 52 possible cards, and we need to choose 5 of them. Now, we aren't replacing cards into the deck after we draw, and also the order in which we draw the cards doesn't matter, and that's why we're using choose instead of permutations. In the numerator for this probability, we just need to write down how many royal flushes there are, but there aren't that many. There's one royal flush possible in each suit, and there are 4 suits. So the number of outcomes that are royal flushes is just a 4. So now we can calculate what this is. 52 choose 5 turns out is something on the order of 2,598,960. Okay. So you can see that as long as we can use all of our counting tricks to figure out the size of the event we want and the size of the sample space, calculating pretty complicated probabilities isn't actually that bad. It's less common, but sometimes we'll need to use our counting tricks to find the size of the events that we're looking for, not just the sample space. So let's look at a couple examples. So let's find the probability of drawing a 4 of a kind in a 5-card poker hand. So the probability of 4 of a kind, I'll abbreviate that, 4 of a kind like this. This is going to be the number of draws that give us a 4 of a kind, so number of 4 of a kind draws with 5 cards, divided by the total number of 5-card hands. But as we mentioned a second ago, the number of 5-card hands, that's going to be 52 choose 5. So all we need to do now is figure out how many ways are there of drawing a 4 of a kind for a 5-card poker hand. To figure out how many ways there are of drawing a 4 of a kind, it's best to think about the choices you would have to make to determine what 4 of a kind you're talking about. So the first thing you'd need to determine if you want to specify a 5-card hand that's a 4 of a kind is which rank you're talking about. You could have a 4 of a kind of 2s or of 7s or of kings or of any rank. So the first thing we need to choose is the rank for the 4 of a kind. And then, so we need to know the number of ranks. After you choose a rank for your 4 of a kind, then you need to choose one remaining card, because choosing the 4 of a kind only tells you 4 cards for your hand, so you have to choose one more card to get that 5th card. All right, now that we've sort of thought about the steps that we would go through to specify a draw that's 4 of a kind, we can just write down how many possibilities there are for each choice in our chain of steps here. So for the number of ranks, there are 13 ranks in a standard 52-card deck. Now we need to multiply that by the number of ways to choose one more card. Well, since we've specified a rank, we've already decided to take all 4 cards of that rank, and that means there are 48 cards left, and we need to choose one of them. So we have 48 possible ways to do that. If you wanted to, instead of 48, you could write 48 choose 1, since we're choosing 1 card from among 48. But 48 choose 1 is 48. If you want to check that with the formula, you can. And in the denominator, 52 choose 5, and that's one that we calculated before. That's 2,598,960. This numerator, if you multiply this out, turns out it's 624. And then if you divide the two, you get about 0.00024. So that's 0.024% chance of drawing a 4 of a kind, which is not very likely, and that's why a 4 of a kind is a really good hand in poker. All right, for our next example, let's imagine that there's a lottery drawing where there are 6 numbers drawn without replacement, and the numbers that we draw are all between 1 and 55. What is the chance of matching at least 5 numbers out of the 6 that get drawn? So in this situation, in a lottery, it doesn't matter what order. If it's a regular lottery, it doesn't matter what order the numbers are drawn in. It only matters which numbers are drawn. And so that means we're going to end up using n choose r instead of n permute r. So let's figure out the probability of greater than or equal to 5 matches. Well, since we're only drawing 6 numbers total, the total number of matches that we can have are either 5 matches or 6 matches. So we could write this as the probability of 5 matches or 6 matches. All right, now that we've expressed our event using one of these key words, or, we can use the formula for probabilities that for OR. So that's the probability of getting 5 matches plus the probability of getting 6 matches minus the probability of getting 5 and 6 matches. Of course, it's impossible to get both 5 correct matches and 6 correct, so this last probability is actually 0. Okay, now we need to work out these individual probabilities. So the probability of getting 5 matches, well, in the denominator for this probability, we need to put the total number of possible lottery drawings. There are 55 numbers to choose from, and we're going to choose 6 of those. So that's 55 choose 6. And how many ways are there to get exactly 5 correct? Well, first, to get exactly 5 numbers correct, first you have to decide which numbers are the numbers that you're matching. There are 6 numbers you could match, but we only want to match 6 of them. So we need to know, out of the 6 possible numbers to match, how many ways are there to choose 5 of them? And that's 6 choose 5. Now we need to multiply by, right? We have already specified by writing down 6 choose 5, we've already specified which of the 6 chosen numbers we're matching. Now we need to choose one more number, but it has to be a number that doesn't match, because we've already matched 5. We want to make sure we don't match 6, because we're going to account for that separately over here. So we need to choose one more number that does not match any of the 6 numbers that came up in the lottery drawing. So we need to choose one more number out of the 49 numbers that are left. And to choose one number out of 49, there are 49 possibilities. Okay, so that's for our first probability. Now for the second probability, again, the sample space is just the total number of possible lottery drawings, and that's still 55, choose 6. And how many ways are there to get exactly 6 matches? Well, to get exactly 6 matches, that's matching every single number, and there's only one way to do that, get them all right. Okay, so now we have everything we need. We just have to do all these calculations. So 55, choose 6. Actually, I'm going to put these over a common denominator. They are over a common denominator, so I can just add the numerators. So the denominator here is 55, choose 6. And that's 28,989,675. And for the numerator, we have, let's see, 6, choose 5, that's 6 times 49 plus 1. And 6 times 49 is 294. Plus 1 is 295. Divided by 28,989,675. Just to actually get a number for this, 295 divided by 28,989,675. So that is approximately 0.00001018. So that's 0.001018%. So your chance of getting 5 or 6 numbers right on this lottery are pretty small.